Hi students, in this first video for online lecture 2, we are going to talk about the last major topic of chapter 1, and that is going to be our dimensional analysis and unit conversion. So, what is the best way of doing unit conversion? It is following a systematic path to go from your original unit to your desired unit. So how can we do that? Well, the best place to start is know where you are and know where you want to go. Let's determine which unit conversion factors you need. It's really important to have this in front of you so that way you know what conversions you are capable of doing and which ones you need to look up. Carry your units throughout the calculation. In many fundamental physical science classes, they kind of brush over units or make you fear units. They're actually your best safety net. You want to be able to cancel them out as you're going along to make sure you're doing the correct multiplication or division. Finally, if all of the units cancel except for the desired unit, our target unit at the end, then you know you've solved the problem correctly. You want to do this all ahead of time so that way you are not doing a bunch of math and ultimately ending up with a wrong answer. Do your preliminary calculation using just the units and then go and do the arithmetic. So a given quantity times a conversion factor should give you the desired quantity. What that looks like is your given unit times your conversion factor. Your given unit should be on the bottom if you're wanting to cancel out something on the top, or if your given unit is on the bottom, we want to have that on the top. We just want to have them more or less divide by each other. So as you can see here, our two given units will cancel, leaving me the desired unit. You're going to see many uses of that over this video. So let's go back to an exam question that I had back in the fall of 2015. This is one of the more difficult unit cancellation problems and problem solving problems that you're going to have for the semester. I want to make nickel wire, and it needs to have a certain diameter of 6.304 times 10 to the minus third inches. We call this 34 gauge. If I have 2.450 kilograms of nickel, I give its density, how long can I make this into a wire? So this is really just a difficult starting place for most freshman students. When I originally gave this problem to my students, many of them didn't even know where to begin. So let's go ahead and break it down into a simple manner before we do any work. This is how I want you to look at this world. So if you can imagine wire as a really, really long cylinder, I am able to use the volume of a cylinder. So what is going to happen in this case is I'm going to solve for h, which is actually be the length. But the nice part about it is I will also have my diameter, which if I cut it in half, I will get 2 radii. So the nice part about this is I actually have a lot of the information, but it just seems to be hidden to start off with. Plus, we need to know a couple of conversions. 1 kilogram is how many grams? Remember that we did this work before, and it is 10 to the third grams, 1,000 grams. Then we now have to make our conversion from our SI units or metric units to our empirical units. This is something that I expect you to know, and that is that you will have 2.54 centimeters per 1 inch. So now that we kind of have a visualization of what we need to do, we can go ahead and start to work on this problem. So let us start with our mass. So we started with 2.450 kilograms. Well, now what we ended up needing to do is going and converting that to grams. So we would multiply that by 1,000, and as you see here, we would get 2,450 grams. So that got us our mass, but we really don't want a mass, and as you can see, we eventually have to go to volume. So that means going through the density. So now what I will do is go and calculate the volume using the density. So I will get 1 cubic centimeter for every 8.91 grams. This is taking the density and flipping it upside down. This will give me a volume of 274.97 cubic centimeters. So now we have a problem. We have our volume in cubic centimeters, but then we have our diameter in inches. We have two conflicting units. So we need to convert one to the other. This is where, in the problem, it could have stated, please give me the length in centimeters, or please give me the length in inches. I'm going to choose to go to inches for the remainder of the problem. In a problem like this on a quiz or an exam, I would ask for the desired unit. So now I need to go and take my cubic centimeters and convert them to cubic inches, which is also a volume. So how do I do that? I would take my 274.97 cubic centimeters and multiply this by our unit conversion. So I need to go to inches, and that is 2.54 centimeters. But notice that I don't have unit consistency. In this case, I only have centimeters, not cubic centimeters. So what I'm able to do is go and cube this entire unit conversion. This means that I would get cubic inches and I would get cubic centimeters. Whatever you do to the unit, you must also do to the number. So as you're doing this calculation, you're going to want to take your 274.97 cubic centimeters and divide by 2.54 cubed. If you do that, you will actually get a volume of 16.78 cubic inches. So now what can we do? Well, now that we have a volume and we know our formula for the cylinder, which would be given on an exam if you don't remember or we use a different shape, I can now set that equal to pi r squared h. Well, we have r, but kind of. As you can see up above, I actually have the diameter, which means I would need to divide it by 2. So if I were to do this problem correctly, I would need to go and divide my left side by pi r squared. So if I do this and say I go and solve for h, my h would be equal to my 16.78 inches cubed over pi, and now my r is going to be my 6.304 times 10 to the minus third, but I need to divide that by 2 in order to get the radius from the diameter, and I will square that. So if I put all of this into my calculator, you will come to find out that my height, which is actually the length of the cylinder, would end up being 5.37 times 10 to the 5th inches. So as you could see, back when you started this problem, you might have been looking at it going, I don't even know where to begin. But as you can start to go and look and use a very methodical plan, it will work itself out. Let's try another example. Here's an example from the fall of 2016. In this problem, I have finally won the lottery, and the first thing that I'm going to do is fill an entire swimming pool with chocolate pudding. I'm going Scrooge McDuck, but instead of gold coins, I'm going to use chocolate pudding. Using the following unit conversions, what would it cost to fill a swimming pool with the dimensions of 15 meters by 8 meters by 3 meters with chocolate pudding. Now, this might seem as a completely crazy problem, but we still can do this very methodically as we're starting to go through. So as you can see here, I have all the unit conversions that I am going to need. So let's look at the problem this way. If I have a swimming pool, I can get the volume by doing length times width times height. So as you can see here, I have a rough sketch of my swimming pool. But then what I need to do is also look at all the other conversion factors that I had back on the last slide. From the volume content, we knew that 1,000 liters is actually 1 cubic meter. That's going to be incredibly helpful for us here in a little bit. So now you can see exactly how my thought process works for this problem. I'm going to take the dimensions of the pool, create a volume. Then I'm going to go from liters to gallons, gallons to cups, cups to boxes of pudding I need to go, and then eventually I need to buy that many boxes of pudding with money. So it's going to be a very methodical plan as I start to go through. So let's go and do that. So using this space here, I need to first start with my volume. So volume is equal to length times width times height. So in this case, that is 15.0 times 8 times 3. And that should give me a volume of 360 meters cubed. But that's not really going to be helpful to us. We have a volume, but now we need to go to liters. So remember that it said back on that volume slide, we could multiply this by 1,000 liters in 1 cubic meter. So if we do that, you should end up with a volume of 360,000 liters. So we've got to liters. So now what we need to do is go to gallons. So this is where, as you can see in this line, I have that by saying 1 gallon is 3.78 liters. That would get me to gallons. But now what you can see is I need to go to cups. So if I do that, I can say that 16 cups is equal to 1 gallon. If I were to go and do that, I can actually get a temporary answer to determine how many cups I currently have in this situation. So I would take my 360,000, divide it by 3.78, and then multiply it by 16. So right now, based off of my answer, I would have a total of 1.52 times 10 times 10 to the 6th cups. Well, now we can see that we are going to get 1 box of pudding for every 4.5 cups. And then finally, our last conversion factor to figure out exactly how much this is going to cost me, I need to put the cost in of each box. So that would be $1.08 for every 1 box. If I do that, I now should have a dollar figure. And if I do this calculation correctly, I should get $365,714. With sig figs, it's probably best, just to make sure that I am safe here, that I should account for $366,000. Now, many of you are going to sit there and say, would Dr. Collins really do that? Well, if I won the lottery for $250 million, $366,000 to have a swimming pool full of pudding doesn't seem like a terrible idea. As you've seen in these two examples, you have to work methodically and use the unit cancellation method in order to systematically work through examples, no matter how ludicrous they are. This now finishes the material for Chapter 1, and you have everything that you need for the first chapter of this course. Have a great day.